I think we did a small, like one class. This question you did now. Please see.
Yes, sir.
I know we have done till this question. Fine. Actually, next is a very small topic which has been asked a certain times is the definition of the differences between average rate and instantaneous rate. Okay. So you have to read it from NCERT and it's very easy topic to understand. You do not have any problem. The only thing that I can tell you right now, you remember average speed and instantaneous speed. It's very similar to that. So average speed is for a period of time and instantaneous for a point of time. Okay, so at a point, if you are calculating the rate of reaction, that will be instantaneous, and if you are calculating the rate of reaction over a period of time, that will be average rate of reaction. ठीक है, so आप इसको एनसीईआरटी से कर लीजिए, ज्यादा कुछ नहीं है इसमें. You will, if they ask any question, then they will ask you guys to write the difference between average rate and instantaneous rate. ठीक है. Next जो आपके पास मेन हम लोगों को पढ़ना है, that is how is the rate of reaction affected? How is the rate of reaction affected? So can I say that a reaction occurs only and only if the reactant molecules, they will collide with each other, they will come into contact with each other. I want your mics on, please. Because ज़्यादा आप लोग को yes sir no sir में answer करना है. Yes, Yusuf and Krishna Priya. If I have A and B as a reactant and A and B are not coming in contact, that means reaction will not happen. Make sense?
Yes, sir.
Reaction will only occur when A and B are coming in contact with each other and they're colliding. Make sense?
Yes, sir.
So if the number of collision per second increases, that will also increase the rate. And if the number of collision decreases, it will decrease the rate. Make sense?
Yes, sir.
Okay. Now, one thing I hope you can understand very easily. Let us suppose we have a small container. Let us suppose we have 10 moles of A and 10 moles of B in a container. Okay. And in the same container, we have 1000 moles of A and 1000 moles of B. Where do you think more collision will occur? Like the first case or the second case?
Second case, sir.
Second case. So we can say that rate is directly proportional to number of moles. Makes sense?
Yes, sir.
And let us suppose that we are just now decreasing or increasing, changing the volume. The number of molecules of A is still 1000, but in a small container. And the number of molecules of A and B are still 1000, but in a bigger container. So what do you think? Where will be the collision more? In the first case or the second case?
Second case.
Second case. Now makes sense because it is a small container. Krishna Priya, आपको समझ में आ रहा है? I need your mic on. You need to answer things.
Yes, sir.
ठीक है. So I can say that if volume is less, then also rate is increasing. So rate is directly proportional to number of collisions, and the number of collisions is directly proportional to number of moles, and inversely proportional to volume. So instead of writing moles upon volume, we can directly write molarity. Make sense?
Yes, sir.
ठीक है, अब देखिए ध्यान से. We have a reaction. A is giving me product. So A is directly proportional. Sorry, the rate will be directly proportional to the concentration. We have just proved that, that the rate is directly proportional to the concentration of reactant. So the R is directly proportional to A, the concentration of A. Makes sense? Yes or no?
Yes, sir.
अब ध्यान दीजिए जरा. Let us suppose we have two reactants, A and B. So rate will be directly proportional to the concentration of A and concentration of B. That also makes sense, I hope. Next we have, let us suppose A and A. Using maths, we can write it 2A. But actually में है क्या? 2A तो 2A क्या है? मतलब you have A is reacting with A. Make sense? Yes or no?
Yes.
ठीक है. अब उसके लिए हम क्या लिख सकते हैं? Rate is directly proportional to A into A, or we can write A square. Make sense?
Yes, sir.
सही है. ठीक है. So this was the first initial thought. ठीक है. This was the initial thought of reactants. How the rate is dependent on the concentration of reactant. This was the first thought. Initially यहाँ से start हुआ है, and you can see it is completely logical. हम लोगों ने start कहाँ से किया? Reaction occurs. So why do reaction occur? Because the reactant molecules, they collide with each other. If we increase the frequency of collision, then the rate will also increase. The speed of the reaction that will which it is occurring, that will also increase. So in order to increase the collision frequency, we can either increase the number of moles or we can decrease the volume. Number of moles upon volume is molarity. So we can say that, okay, fine, rate is directly proportional to the concentration of the reactive molecules. And this particular law is known as the law of mass action, which says that according to this law, rate of reaction is directly proportional to the product of the concentration terms of each reacting species at constant temperature. है ना, जो कि हम लोगों ने यहाँ पे देखा है, AB है तो directly proportional to A into B. So for a general reaction, what we can write, A plus BB gives CC plus DD. Here small a and small b are the stoichiometric coefficient. I can say that rate is directly proportional to the concentration of A to the power small a, concentration of B to the power small b. And rate is equal to the rate constant multiplied by concentration of A to the power A, B to the power B. ठीक है, ये तो आप लोग मतलब ये तो बहुत स्टार्टिंग फेज था इसका केमिकल काइनेटिक्स. नाउ आई वांट योर अटेंशन. ठीक है, प्लीज. यहां तक कोई बहुत ज्यादा कॉम्प्लिकेटेड चीज नहीं थी, बट थोड़ा सा हम यहाँ पे अटेंशन मांग रहे हैं. अब देखिए, इट इज very much understood that all the chemicals, they are not equally reactive. Some chemicals are more reactive than the others. Make sense, yes or no?
Yes,
सही
sir.
है. ठीक है, थोड़ा डिस्कशन टाइप रखेंगे तो ज्यादा अच्छा लगेगा. कृष्ण प्रिया, यूसुफ, यू कैन हैव योर माइक्स ऑन इफ देयर इज नो बैकग्राउंड नॉइस. ठीक है, आई कैन हियर देयर इज नो बैकग्राउंड नॉइस, तो आप लोग माइक ऑन करके ही रखें ताकि हमको वेट ना करना पड़े आप लोग के आंसर के लिए. ठीक है, कृष्ण प्रिया, जस्ट वेटिंग फॉर यू टू टर्न द माइक ऑन. यस, थैंक यू वेरी मच. It is very much understood na कि some of the chemicals are more reactive than the others. Correct है?
Correct, sir.
So let us suppose we have A and B. These are reacting with each other. Okay, and let us suppose the reactivity of A is greater than B. So now, increasing the concentration of A and increasing the concentration of B will not have the same effect on the rate. I can also say that since A is more reactive, the rate of reaction will be much higher if I increase the concentration of A rather than that of B, because A is more reactive. आप reactive species की concentration बढ़ाएंगे, obviously क्या होगा, वो ज्यादा react करेगा, and since it is more reactive, what will happen? More collisions will occur. Make sense?
Yes, sir.
ठीक है. So from here we can say that it not only does depend the rate, it does not only depend on the stoichiometry, but rather it more depends on the chemical species A and B. ठीक है. So taking this into consideration, कभी कभी ऐसा हो सकता है B is not reactive at all. Like no matter how much concentration of B you are increasing, it is not affecting the rate of reaction because A is the one which is more reactive. Fine. So they said that, okay, fine, we cannot really say that this A and this B in reality. This was the initial theoretical format. There was no experimental data that was used for this particular rate law. So they started using some experimental data and they found out that, okay, fine, we cannot really say that this A and this B are the stoichiometric coefficient in the chemical reaction. We have to look at the experimental data. ये जो reaction लिखा है, ये तो theoretical हो गया. It's completely theoretical. You don't need any kind of experiment to write this type of reaction. है ना? तो rate law expression के लिए, now this is the real rate law expression. ठीक है? The initial that was law of mass action. That was the initially proposed rate law, but that is not true at all. Conceptually, it was very fine. That is why it is being taught so that you can develop some kind of deduction criteria कि आपने reaction कराया, reaction होगा तब जब collision होगा, collision को कैसे increase और decrease किया जा सकता है. So those type of things should be present in your brain in order to understand about the reactivity, है ना, कि rate of reaction कब ज्यादा होगा कब कम होगा. But in reality, what is there? In reality, we have the rate law expression, which is the mathematical expression in terms of concentration of reactant, which actually determines the rate of reaction is called rate law expression. अब rate law expression क्या होगा? For a reaction A, B, B, C, C, D, D. That means A, B, C, D, the small a, small b, small c, small d, they are still the stoichiometric coefficient of the reacting species and the products. But the rate law expression says that rate of reaction will be equal to K some constant multiplied by the concentration of A to the power P. Now P is something that is experimentally determined, multiplied by the concentration of B to the power Q, and Q is also experimentally determined. Now rate, it is the rate of reaction. This K is the rate constant. This concentration of A is the This A in square bracket is the concentration of A, B in square bracket is the concentration of B, P is known as the order with respect to A, and Q is known as the order with respect to B. I would like you guys to write this whole thing. Please write it down so that आगे हम लोग कुछ सवाल वगैरह करें तो वहां पे आप लोगों को मतलब आसानी होगी, मतलब सॉल्व कर पाए कम से कम आप लोग. ठीक है? I will give you time. Please write this down. Raise your hand once you're done. You don't need to write this part. Please don't write this part. You just need to write this. So, Krishna Priya, did you get time to revisit what we did in the last lecture? I don't think so, no?
No, sir. My model exams are coming up, so I was preparing for all that.
तो उसमें केमिकल काइनेटिक्स भी तो आ रहा होगा.
Yes, sir.
तो उसकी प्रिपरेशन में आप ये टाइम यूटिलाइज कर सकते थे ना, इस चीज को कर सकते थे आप.
I did chemical kinetics yesterday. Like I revised the entire chapter yesterday.
अच्छा, you revised the entire chapter. Okay, fine. Yusuf and Krishna Priya, calculate the order of reaction. You have to send the answer on my Zoom chat. Mm, Yusuf, I think you want to revisit the first one. Order will be equal to 1 by 2 plus 3 by 2. So 2 is here, 4 by 2, that will be equal to 2. है ना? And here 3 by 2 minus 1 will be equal to 3 by 3 minus 2 by 1. Sorry, 3 minus 2 by 2, which will be equal to 1 by 2. ठीक है, so इसको आप देख लीजिए एक बार. I think हड़बड़ी में आपने गलती कर दी. Moving on, the note is, we will see this particular thing later on. The rate constant does not change with the concentration of reactant, and the rate law expression may or may not be same as the law of mass action. We have already discussed that कि ये जो आपके पास P और Q है, ये आपके पास stoichiometric coefficient हो भी सकते हैं, नहीं भी हो सकते. आप लोग नहीं है मान के चलिएगा, until unless it is explicitly written that stoichiometry ही आपका क्या है, order of reaction है. And when we will be learning about the mechanism, then also we will take a generalization कि कब जो आपके पास order है, that will be equal to the stoichiometric coefficient. Now we have a question. The question is, a reaction is first order with respect to A and second order in B. Write the differential rate equation. How is the rate affected on increasing the concentration of B? 3 times how is the rate affected by the concentration of both A and B? This question is in NCERT and it has been asked multiple times in the board examination. ठीक है, multiple times. 3 मार्क्स का सवाल है, बहुत ही आसान सा. राइट द डिफरेंशियल रेट इक्वेशन. तो इसके लिए हम बस बता दे रहे हैं, थोड़ा सा आपको ये अजीब लग रहा हो. व्हाट इज डिफरेंशियल रेट इक्वेशन? सो यू कैन राइट जस्ट रेट क्या होता है, चेंज इन कंसंट्रेशन ऑफ ए डिवाइड बाय चेंज इन कंसंट्रेशन ऑफ डी ए बाई डी टी, है ना? ये तो होगा. लेट मी राइट द आंसर फॉर द फर्स्ट वन हियर. डी ए अपॉन डी टी is equal to k into the concentration of A to the power 1 as they have written multiplied by B to the power 2. आप डी अपॉन डी टी की जगह ना रेट भी लिख सकते हैं. ठीक है, दिस इज द डिफरेंशियल रेट इक्वेशन, डोंट वरी अबाउट इट. k a to the power 1 and b to the power 2. Okay, I've got one answer. For the second one, how is the rate affected on increasing the concentration of B 3 times? Fine. How is the rate affected when the concentration of both A and B are doubled? Okay. Krishna Priya, any answers? Yeah, fine, correct. Yes, very good, correct. So this is quite logical also, and if you want to have like a formula, then you can have a formula also. this is the way to do it, that is a longer way, that this is the rate equation, and as I have written already. Second question is R1 में आप क्या ले ले, as it is Ka and B square. R2 is Ka, thrice the concentration of B will be 3B squared, 2 upon 1, R2 upon R1 will be equal to K into concentration of A into 3B square. R1 is K concentration of A into B square. K and concentration of A will be cancelled, 3 square and B square. So B square will be cancelled and R2 will upon R1 will be equal to 3 square. So here we have R2 is equal to R1 multiplied by 3 square, that is 9. अब यहाँ पे आप देखिए जरा, तो I have generalized it to the form कि ये जो आपके पास 3 है ना, this 3 is the change what you are changing, you are tripling it. ठीक है, और 2 क्या है आपका, that is the order of the species that you are tripling. आप क्या कर रहे थे, B को क्या कर रहे हैं, ट्रिपल कर रहे हैं, और B का ऑर्डर क्या है, 2 है. So in general you can write that R, वो हमने आगे लिखा हुआ है, I will not write it right now. So you can write something like this: R2 is equal to R1 multiplied by change in the concentration, जिसका भी आप concentration change कर रहे हैं, to the power P into change to the power Q. ठीक है. So for the first question, increase in concentration of B 3 times, तो क्या हो जाएगा, R2 is equal to R1. आपने क्या चेंज किया, 3, ट्रिपल किया तो 3 हो गया. And what is the order of B? It is 2. So R1 into 3 square, that is equal to 9. Second question जो था हमारे पास, that was increase, what was it? Both A and B are doubled. ठीक है. So A को भी आप क्या कर रहे हैं, 2 times, and B को भी आप क्या कर रहे हैं, 2 times. ठीक है. Now R2 is equal to R1 multiplied by, for A we are doubling it. What is the power of A? It is 1 multiplied by what we are changing B. What we are doing, we are doubling it. So 2. What is the power of B, or rather order of B, that is equal to 2. This will be equal to R1 into 2 का cube, that will be equal to 8. So R2 is equal to 8 R1. ठीक है, आपको इतना लिखना पड़ेगा बस, nothing else, है ना. You have to write just this much. Okay. So does this make sense? Yes or no? Please tell me, guys. ये आप
Yes,
लोगों को
sir.
समझ में आया? ठीक है. You can directly answer, no need to use the formula, अगर logic, because it is completely logical, थोड़ा सा math से बस, है ना. So चलिए हमने क्या है, how is the rate affected when the volume of container is half. अभी जरा, how is the rate affected when the volume of container is half, इस तरह के भी सवाल आ सकते हैं, not regarding the concentration of increasing concentration, but rather decreasing the volume or increasing the volume. ठीक है. So how is the rate affected when the volume of container is half? यहाँ पे देखिए, we have R, that is equal to, R is directly proportional to molarity. Molarity is moles upon volume. So R is 1 upon V. ठीक है. So change क्या कर रहे हैं हम, volume को change कर रहे हैं, तो change को हम क्या लिख देंगे, 1 upon delta. जैसे हमारे पास था ना, R2 is equal to R1 change to the P change to the Q. Now here we'll write R2 is equal to R1, and what we are changing, we are halving the, we are doing half of the volume. And volume is inversely proportional to 1 upon 1 by 2, 1 upon 1 by 2, इसका power 1, इसका power 2. So denominator of denominator is numerator, so it will come above. Denominator of denominator is numerator, so it will come above. And you will have R2 is equal to R1 into 2 square, that is still 8 R1. अब इसमें आप लोगों को शायद समझ में ना आया हो. What I will do, I will do one question in which we are doing something else. ठीक है, not, we are not halving it, but let us suppose इसी में हमने ऐड कर दिया. आपके पास we have the same equation, जो हमारे पास rate law है, it is still the same, और this will be fifth. ठीक है. So rate is equal to K into A to the power 1 and B to the power 2. How is rate affected when volume of container is doubled? ठीक है. जब वॉल्यूम ऑफ कंटेनर को आप डबल कीजिएगा ना, is doubled, तो the concentration of A and B both will change, because both A and B are inside the container itself. ठीक है. तो हमारे पास when volume, जब वॉल्यूम चेंज होता है, तो हमारे पास क्या है, R2 is equal to R1 multiplied by 1 upon whatever change we are doing to the volume की power. What is here, the power 1, ये जो भी इसमें चेंज है, upon 1 upon whatever change we are doing to the volume and square. ठीक है. So this 1 and this 2 is coming from A and B. ठीक है. So R1 into 1 upon 2, because we are doubling it, multiplied by 1 upon 2 square. This is R2. So R2 will be equal to R1 upon 2 का क्यूब क्या हो जाएगा 8. ठीक है. So R2 is R1 upon 8. Make sense? ये सुनो, ये समझ में आया आप लोगों को? कृष्ण प्रिया यूसुफ.
Yes, sir.
ठीक है. तो जब आपके पास कंसंट्रेशन है, सो देन फॉर कंसंट्रेशन R2 is equal to R1 multiplied by whatever change we are doing to the power P into whatever change you are doing to the power Q and so on if you have more reactants. This is for concentration and for moles also, which is directly proportional. ठीक है, moles के लिए भी यही है. But for volume, R2 is equal to R1 multiplied by 1 upon whatever change in volume you are doing to the power P multiplied by whatever change in the volume you are doing to the power Q and so on. ठीक है. Yusuf, does this make sense for you?
Yes, sir.
ठीक है. Now we have a question. इस तरह के भी सवाल आपके पास आ सकते हैं. That determine the order of reaction. Determine the order of reaction from the following data. So what data do we have? Here we are having some experiments and initial concentration of NO, that is reactant, O2, that is reactant, and the initial rate of formation of NO2, that is the rate. ये आपको बेसिकली रेट बता रहा है. एंड दीज आर द रिएक्टेंट्स, है ना, ये दोनों रिएक्टेंट है. लेट मी सी व्हाट कलर विल सूट हियर. आई थिंक दिस कलर. दिस इज रेट एंड दिस इज रेट. अब यहाँ पे यू कैन डायरेक्टली गेट द ऑर्डर ऑफ रिएक्शन बाय लुकिंग एट द वैल्यूज इटसेल्फ, है ना. और ये जो सवाल है ना, इसमें लंबा भी चला जा सकता है. यू कैन सॉल्व इट और यू कैन डिड्यूस फ्रॉम द डेटा डायरेक्टली. सो इफ यू लुक, अच्छा एक बात बताइए, NO का एक अलग ऑर्डर आएगा एंड O2 का अलग ऑर्डर आएगा. मेक सेंस? ये सुनो प्लीज टेल मी.
Yes, sir.
ठीक है. नाउ चूज टू एक्सपेरिमेंट्स. लिसन टू मी वेरी केयरफुली. चूज. अच्छा, आप लोग को ये आता है क्या करने के लिए? हम बेकार फिर इतना समझा रहे हैं. आप ये एक बार अटेम्प्ट कर लीजिएगा फिर. यूसुफ एंड कृष्ण प्रिया, कैन यू गाइस डू दिस?
I can try, sir.
कृष्ण प्रिया, व्हाट अबाउट यू?
Yes, sir.
हाँ ठीक है, करके देखिए जरा. एंड अगर कुछ प्रॉब्लम आई तो फिर हम आपको आगे एक्सप्लेन करेंगे और ऐसे भी एक्सप्लेन कर देंगे. ठीक है, जिस पर प्लीज ट्राई इट. आई थिंक इट विल बी मोर बेनिफिशियल फॉर यू. Okay, Yusuf, I think that makes sense. Just waiting for order of NO. What about NO, Yusuf? अच्छा, थोड़ा टाइम लग रहा है. Other side. Krishna Priya, are you stuck? Yes, Krishna Priya. Acha, you are getting it. Okay, okay, fine. What about O2? चलिए ठीक है,
No,
देखिए एक तो इसका शॉर्ट
that
मेथड
is
है.
wrong.
कृष्ण प्रिया, you tell me.
That is wrong.
That is wrong. So what is
Yeah.
right?
Hold on a second. I'll do that again.
So do we have to find the K as well?
You have to find what? K.
Yeah.
Yeah, you can, but not in this question.
Like,
Your answers are correct, by the way. No.
how to find K?
So you have calculated the K.
Mhm.
Yeah, you can send it. You have calculated.
No, I'm asking how do we calculate K?
अच्छा, how do we calculate? ठीक है, I will explain that one. No problem. Yes, Krishna Priya.
How
O2.
do you, I not get the order of O2?
ठीक है, देखिए. So I think you are doing all those calculations now, taking experiment 1 by experiment 2 and all of those things, right?
Yes, sir.
ठीक है, fine. That's also fine, completely fine. लेकिन थोड़ा intuitiveness रखिएगा because this type of question has been asked for 1 marks MCQ. ठीक है? So I hope you can understand कि बहुत ज़्यादा calculation नहीं चाह रहा है CBSE. They want you to look at the table and then deduce it. ठीक है? So I will tell you simple formula. First of all, आपको किसका निकालना है बताइए. O2 का निकालते हैं पहले. ठीक है? O2 का. So choose two experiment in which the concentration of NO is same and O2 is different. NO आपको O2 का निकालना तो O2 का अलग कंसंट्रेशन होना चाहिए, NO का सेम and O2 different. Yes, Krishna Priya. Any two reactions in which the concentration of O2 is different and the concentration of NO is same.
Sorry, sir.
You have to choose two experiment in which the concentrations of NO is same and the concentrations of O2 is different.
Oh, okay. Experiment 1 and 3.
Very good. ठीक है. चलिए. So in experiment 1, NO is 0.30. Experiment 3, NO is 0.30. ठीक है. What is happening to the concentration of O2?
It doubled.
डबल. तो डबल हुआ होगा और इसके ऊपर कोई पावर होगा. लेट मी अज्यूम P. है ना. चेंज अगर आपको समझ में आ रहा हो, we did earlier ना, whatever change to the power make sense. ठीक है. ऐसे लिख
Yes, sir.
लीजिएगा 2 to the power P. Now what is happening to the rate? What is happening to the rate?
It becomes 0.5 times.
No, no, no. 1 से 3 जा रहा है ना. So 0.96 से 0.9192. इसमें क्या हो रहा है? From here to here.
Increasing.
हाँ, लेकिन क्या, like, is there any factor by which it is increasing? डबल हो रहा है, ट्रिपल हो रहा है, ये देखिए. I hope you can guess it. Just look at the last digit of first experiment. It is 6. The last digit of the third experiment is 2. So what do you multiply to get? Yeah,
By 2.
yeah, correct. Very good. So when we are doubling the concentration of O2, rate is doubling, है ना? Make sense? ठीक है.
Yes, sir.
तो 2 to the power 1. Make sense?
Yes, sir.
तो अब क्या हो जाएगा यहाँ पे? P is equal to 1. ओके. जी बताएं. यस कृष्ण प्रिया. मेक सेंस? यस और नो?
Yes, sir.
ठीक है. क्या करना है आपको? सी हाउ टू राइट इट. अब देखिए, बहुत ज्यादा आपको लिखने की जरूरत नहीं है. व्हाट यू विल राइट फ्रॉम एक्सपेरिमेंट 1 and 3. फ्रॉम एक्सपेरिमेंट 1 and 3 जो सेम है उसको लिखने की जरूरत नहीं है. यू डोंट नीड टू राइट दैट. व्हाट यू विल राइट, पहले आप ना ऐसे अज्यूम कर लीजिएगा. लेट रेट इज इक्वल टू K इंटू द कंसेंट्रेशन ऑफ NO टू द पावर P एंड O2 टू द पावर Q मान लीजिए आप. ठीक है. सो O2 का निकालना है तो 1/3 से. तो फिर क्या कीजिएगा? 1 0.30 डिवाइड बाई, या फिर जो बड़ा नंबर है ना उसको ऊपर ले लीजिए आप तो ज्यादा बेहतर होगा. इजियर टू डू कैलकुलेशन. सो 0.60 डिवाइड बाई 0.30. दिस इज द चेंज कंसेंट्रेशन. क्या लगा दीजिएगा? पावर Q, because it is O2. This will be equal to 0.192 डिवाइड बाई 0.096. ठीक है. इसके ऊपर कोई पावर नहीं, बिकॉज रेट में कोई पावर नहीं होता है. सो दिस इज 2 जा, here also 2 जा. So 2 to the power Q, 2 to the power Q is equal to 2 to the power 1. So Q is equal to 1. Same thing we can do for NO, है ना. NO के लिए हम क्या ले लेंगे? Equation 1 and equation 2 I can take. So from experiment 1 and 2. ठीक है. तो 0.3, हाँ तो 2 को हम लोग ऊपर लिखेंगे. 0 पॉइंट आई कैन राइट दीज टू आर डिफरेंट ना. 0.60 डिवाइड बाई 0.30 टू द पावर P इज इक्वल टू 0.384 डिवाइड बाई 0.096. ठीक है. नाउ दिस विल बी 6 4 आप मल्टीप्लाई करके देख लीजिएगा. इट 2 3 ऐसे ही रहता है नंबर सब. ठीक है. दिस इज 4 एंड दिस इज 2. So you can write 2 to the power P is equal to 4. Now 4 can be written in the power of 2 as 2 to the power 2. This will give you P is equal to 2. Make sense? Yes, Krishna Priya.
Yes, sir.
ठीक है. हो जाएगा ना ऐसा सवाल. अब नेक्स्ट इज समटाइम्स दे आस्क यू टू कैलकुलेट द रेट कांस्टेंट टू. है ना. रेट कांस्टेंट भी कैलकुलेट करने के लिए बोलते हैं. सो यू टेक द फर्स्ट एक्सपेरिमेंट एंड यहाँ पे रेट है आपके पास So you will plug in the values just, है ना? अच्छा, रेट आपके पास रेट इज इक्वल टू के इंटू द कंसंट्रेशन ऑफ NO टू द पावर P मल्टीप्लाइड बाय O2 टू द कंसंट्रेशन टू द पावर Q. So rate constant will be equal to the rate upon the concentration of NO, है ना? तो rate upon concentration of NO to the power P and O2 to the power Q. So rate is 0.096 divided by what is NO is 0.3 का square multiplied by 0.3. ठीक है, तो this will be 0.3 का cube, 0.096 divided by 0.3 का cube. So you will calculate this value और ये rate constant आ जाएगा यहाँ से. Make sense? Yes or no, please tell me.
Yes, sir.
ये जरूर आप समझ गया.
Yes, sir.
ठीक है. We will see, look at those questions when we have to calculate the rate constant also. ठीक है. तो ये हम लोगों ने, this is the whole thing. But what is this? Oh, चल ठीक है, ये किसी दूसरे चैप्टर का है. Now, moving on. I think you will have at least one question here. हाँ जी, ठीक है. चलिए जरा इस सवाल को कीजिए. हाँ, बस हम एक आप लोग को हिंट दे देते हैं दैट व्हाट यू कैन डू इज रेट में ना 10 टू द पावर माइनस 3 10 टू द पावर माइनस 3 10 टू द पावर माइनस 3 के फॉर्मेट में रखिएगा. सो यू विल बी हैविंग, यू इट विल बी इजियर फॉर यू गाइस टू कैलकुलेट यहाँ पे. ठीक है, मेक सेंस इज नो?
Yes, sir.
सवाल को देख लीजिए, सेम सवाल है बिल्कुल. चलिए प्लीज ट्राई दिस डाउन. एंड ऑल्सो प्लीज रिमेंबर दैट 2a प्लस b यहाँ पे जो स्टोइचियोमेट्रिक कोएफिशिएंट है, दे डोंट हैव एनीथिंग टू डू विद द ऑर्डर ऑफ रिएक्शन. यू हैव टू कैलकुलेट द ऑर्डर ऑफ रिएक्शन. Okay, I've got some answers. Okay, Krishna Priya. Yusuf, are you having difficulty?
No, sir. I'm calculating K. I got all the values.
Okay, fine. Can you send me the orders?
Sure, sir.
Okay, both of you have got the same answers. Let me just check. So you got the K also? Okay, fine. So we have to, okay, if I want to calculate, so I have to use this. Okay, B is same here and A is different. So this is multiplied by 4. And what is happening to the reactant? So 6 4s are 24. So I can say that with respect to A, rate is equal to K into the concentration of A to the power 1. And if I use the second and the third, I can say that we are doubling we are doubling it, and 72, I think it will be 4s are, 4s are 28, fine. So B to the power 2. Okay, very good. That's really nice. ठीक है, बहुत बहुत बढ़िया हो गया फिर तो। चलिए, तो read constant both of you got as 6. उसको भी एक बार हम कंफर्म कर लेते हैं. So I will put it in the first experiment because it is quite easy. So K, it is equal to rate upon the concentration of A and concentration of B, right? So A to the power 1 and B to the power 2. So rate is 6 into 10 to the power minus 3 divided by 0.1 into 0.1 square. This will be equal to 6 into 10 to the power minus 3 upon 10 to the power minus 3. This will be equal to 6. ठीक है. Now अब यहाँ पे एक चीज आएगी, that will be the what I would say, the unit of rate constant. ठीक है. तो रेट की जो यूनिट है, that is what, moles per liter per minute. ठीक है, moles per liter per minute. देखिएगा, we have moles per liter per minute. Now per minute will not be cancelled. Concentration terms क्या होगा? मोल्स. अच्छा, एक काम करते हैं हम ना, मोल्स पर लीटर आप लोग को बहुत ज्यादा ये लगेगा, मोलर लिख देते हैं हम कैपिटल एम से, मोलर. और यहाँ पे क्या है आपके पास, मोलर इनटू मोलर स्क्वायर, बिकॉज बी का स्क्वायर हो रहा है. फाइन. So for A, we will have 0.1 mole per liter, to molar, and for B, we'll have 0.1 molar plus into 0.1 molar into 0.1 molar, so it will be molar square. So molar and molar will cancel each other out, and it will become mole to the power minus 2. अब यहाँ पे जो आपके पास यूनिट होगा, this will be, सिक्स वैल्यू हो गई है आपकी, it will be molar minus 2 minute inverse. And when we are going to write the whole thing, then it will be K is equal to 6. What is molar? It is moles per liter to the power 2 minute inverse. We can write this as 6 mole square liter, no, minus 2 है ना, my bad, minus 2. So mole minus 2 liter square minute inverse. This will be the value of K with the units. Does the unit make sense? Yes or no, Krishna Priya, Yusuf?
Yes, sir.
Yusuf, what about you?
Yes, sir.
पक्का? जी यूसुफ.
Okay, sir.
नहीं, your yes was not very convincing. That is why. Fine. Now we have the rate constant. What is rate constant? देखिए, किसी भी constant को define करने का एक ही तरीका होता है. जैसे मान लीजिए, we have R is equal to K into the concentration of A to the power P multiplied by B to the power Q or so on. ठीक है. Now, if I take the concentration of A as 1 molar, B as 1 molar, so in this case, what would happen? In this case, whatever we, like P is whatever, it doesn't matter, right? Because what 1 to the power of anything will be equal to 1. and here also 1 to the power of anything will be equal to 1. So when the molarities is 1, then the rate of reaction become equal to rate constant. So this is how we define any constant. ठीक है, solutions में भी आप लोगों ने पढ़ा होगा जब हम लोग qualitative property पढ़ रहे थे, that the side on which the is present ना, ये reactant के side है, तो इनके जो variables उनको 1 कर दीजिए. So when the what is rate constant? Rate constant is the rate of reaction when the concentration of each reacting species is equal to 1. ठीक है, so this is the definition we have written here. It is defined as the rate of reaction when the concentration of each reactant is 1 mole per liter. Rate constant is also known as the specific rate of reaction. Now, what are the characteristics of rate constant? It gives an idea about the speed of reaction, because जब आपने standard condition 1 molar पे रखा है, and if the rate constant is high, it's very large, that means the reaction will be faster. Greater the value of K, faster is the reaction. Different reaction will have different values of K. Rate constant is independent of the concentration of reactant, because concentration को constant रख के rate constant निकलता है. ठीक है? So it is not going to change when you are going to change the concentration. Rate constant changes with changes in temperature. क्योंकि temperature change करेंगे तो number of collisions ज़्यादा हो जाएगा. And we will look at this particular factor, the fourth factor, at the end of the chapter in the Arrhenius equation, how rate constant is dependent on the change in temperature. So these are the characteristics of rate constant. Next, we have the order of reaction. So we have seen order of reaction already. We are just going to define it now. It is defined as the sum of the powers of concentration terms in the rate law expression. Now, there's some remarks of order of reaction which are quite important, because there is another term that we are going to study later on, that is molecularity of reaction. So when they ask you the difference between order of reaction and molecularity, so you will write the remarks point. एक तो definition तो हो ही जाता है, 1 point of difference. The other points of difference will be from the remarks of order of reaction. You will write molecularity of reaction और उसके remarks होंगे वहां से. So first of all, order of reaction, it is experimentally determined. How do we know that? Because whenever we want to determine the order of reaction, we should process the experimental data. Okay, so this is the first remark regarding the order of reaction. Next is, it can be 0, positive or negative, or even fractional. It determines the rate of reaction. If the order is high, then the reaction is generally faster. It changes with temperature, pressure, etc. It may or may not be same as the stoichiometric coefficient. You have seen all of these points previously also, but these remarks are important because they can ask you the difference between order and molecularity. वहां पे ये काम ज़्यादा है. ठीक है. Now moving on, we have the units of rate constant. ठीक है. Units of rate constant के लिए क्या होगा? दो चीजें आपको याद रखनी है. Rate of reaction will always have moles per liter per second. Concentration is always taken as moles per liter. If gaseous species are present in the overall reaction, then what do we take? We take ATM as concentration as the unit. ठीक है, तो हम लोग ATM लेते हैं instead of what? The mole. Instead of concentration, we take the pressure, that is ATM. That is in ATM, sorry. So there are different order of reaction, and for each of them, we are going to calculate the unit of rate constant. So for zero order, please थोड़ा सा ध्यान देंगे अब यहाँ पे, है ना? Please ध्यान दीजिएगा. Rate is equal to the rate constant into the concentration of A to the power 0. So when anything is to the power 0, it becomes 1. So the rate constant and the rate of reaction will be completely equal, and they will have the same units. In the first order reaction, we have R, that is equal to K multiplied by the concentration of A. K is equal to the rate of reaction divided by the concentration. The unit of rate of reaction is mole per liter per second. The concentration of A will be written as moles per liter. So mole and mole will be getting cancelled. Liter inverse will be getting cancelled. You'll be remaining with only one thing, that is second inverse. Okay? So second inverse is the what? Is the unit of the first order reaction. For second order, you do the same thing. You will get mole inverse liter per second. Mole inverse liter per second. Now, ये तीनों आपको याद रहना चाहिए. There are two types of questions that can be asked. आपको या तो दिया रहेगा, आपको दिया रहेगा order, और आपसे पूछा जाएगा unit. Or it can be the other way around. You have been given the unit and you are getting asked about the order of the reaction. ठीक है, तो अब ध्यान से देखिएगा जरा. We have a list here. जब आपके पास zero order है, it is moles per liter per second. So we can generalize. We can write it as moles per liter by 1 minus 0, second inverse. When you have order as 1, then we can say that it is second. लीटर 0 को छोड़ दीजिए, अभी समझ में नहीं आएगा. सेकेंड इनवर्स, सो आई कैन राइट मोल्स पर लीटर 1 minus 1. Second inverse. When it is 2 mole, mole inverse liter second inverse, so I can write it as 1 minus 2. So this is the general formula. If you have been given the order, how to write the unit of K. If order is given and order is equal to n, then the unit of K is equal to moles per liter 1 minus n second inverse. ठीक है. If unit of rate constant is given, अगर आपको इनमें से यूनिट दिया हुआ है किसी का, ठीक है, तो आप क्या कीजिएगा, पावर ऑफ एल जो भी होगा उसमें 1 ऐड कर दीजिएगा. एज यू कैन सी, एल की पावर यहाँ पे क्या है, -1. -1 + 1 विल बी इक्वल टू 0. व्हाट इज द पावर ऑफ एल इन द सेकंड, इन द फर्स्ट ऑर्डर, इट इज 0. तो इसमें आप एक ऐड कर दीजिए, यू आर गोइंग टू गेट द आंसर एज 1. तो 1 इज द ऑर्डर. व्हाट इज द पावर ऑफ एल हियर, इट इज 1. सो व्हेन यू आर गोइंग टू add 1 to it, you are going to get the order of reaction that is equal to 2. तो अब यहीं से आप बस इस चीज को नोट डाउन कर लेंगे ना, then you will answer very easily these questions. चलिए, फर्स्ट और सेकंड आंसर बताइए जरा. आइडेंटिफाई द रिएक्शन ऑर्डर फ्रॉम ईच ऑफ द फॉलोइंग रेट कांस्टेंट. आपको यूनिट दिया हुआ है ना, देखिए यूनिट इज गिवन और आपसे ऑर्डर पूछा हुआ है. आई थिंक यू गाइस कैन आंसर वेरी क्विकली. You just need to look at the power of L and add 1 to it. You will get the order of reaction for the first and the second one. L +1 कर देना बस आपको. What happened? Krishnapriya and Yusuf, नहीं आ रहा समझ में. अच्छा, I'm getting answers. Yes, Krishnapriya, that is correct. What about you, Yusuf? Uh, Fine. Sorry. Krishnapriya, पहला वाला सही नहीं है आपका. हाँ, Yusuf, yours is correct. My bad. Krishnapriya, look at the first one. Liter +1. Power of liter +1 you have to do. I think you want to change the answer. Krishnapriya, power of liter +1. Yes, correct. Very good. Now, let me just see the answers यहाँ पे लिखे हुए हैं. लेकिन आपने आंसर तो देख लिया होगा, but still. So here we have unit of the rate of reaction is same as that of rate constant for. ठीक है, we have seen that it is same for zero order reaction, है ना, जिसकी हम लोगों ने यहाँ पे देखा था. That K is equal to R हो जाता है for zero order reaction. That is why their units are also same. This question was asked in 2023 paper. Fine. So see, this is also done. We can move on to the next one if we have. चलिए इसको कर लीजिए, उसके बाद we are going to end this class. Assertion reason है. What was answer? चल ठीक है, देखिए जरा। कृष्णा प्रिया, आर यू गोइंग टू आंसर?
Yes, sir. Hold on.
Yeah, sure. Okay, what answer? Oh, A and D. How D? This is a correct statement, right? For zero order reaction, unit of rate constant and rate of reaction are same. This is true. Rate of reaction for zero order reaction is independent of the concentration of reactant. So if I make a equation from here, rate of reaction of zero order, it is independent of concentration of A, that is equal to K. And this is the reason why rate constant and rate of reaction, they have the same units, right, Krishna Priya?
Yes, sir.
So not only both the statements are true, reason is the correct explanation of assertion also. How did you end up writing D?
Sir, I read both A and R are true.
Okay, fine. It is false. हमने मतलब दिया क्या? We write it properly. It is false. ठीक है. Fine. So that's it for today. See, Krishna Priya and Yusuf, both of you guys, you have notes. ठीक है. तो next class में जो that is tomorrow, I hope you guys will take a printout of the notes and then you can scribble some things down there in the notes itself. Or like I will be ending the classes. Usually I will be ending it a bit early. ठीक है. Because see, we have covered at least 2 days of content, है ना? 23 and 30th. We'll be starting with mechanism. बहुत ज्यादा अगर एक दिन में हम पढ़ा देंगे, if I cover too much of the syllabus ना, तो फिर ये आपके लिए भी थोड़ा मुश्किल हो जाएगा. So if we continue this particular place, then tomorrow we'll be over with 1st November, 6th November. Then next week we'll be done with this chapter. ठीक है? So even if we continue with this pace, I hope we will be fine. And we are doing solutions here. We are doing solutions here. ठीक है? चलिए. So that's it for today. Please revise this. ठीक है. और जब थोड़ा सा स्पीड हमको लगेगा कि दैट ओके फाइन आई कैन इंक्रीज द स्पीड नाउ, देन आई विल इंक्रीज द स्पीड देन. ओके, चलिए. थैंक यू गाइस, थैंक यू वेरी मच. प्लीज रिवाइज वॉट एवर वी हैव डन फ्रॉम द नोट्स दैट आई हैव सेंट यू राइट नाउ ना, उससे प्लीज एक बार रिवाइज कर लीजिए एंड जस्ट नोट डाउन सम इंपॉर्टेंट पॉइंट्स. आप लोग दोनों का ही अप्रोक्सीमेटली केमिकल काइनेटिक्स इज फाइन टिल हियर. नेक्स्ट जो आपके पास आएगा क्लास, दैट इज मैकेनिज्म. मैकेनिज्म इज वेरी थ्योरेटिकल इन नेचर. ठीक है, जिसमें से कुछ सवाल आते हैं, वी विल डू दोस क्वेश्चंस. And see, देखिए बेसिकली हमने whenever I do any type of chapter, उसमें सवाल बहुत ज्यादा, I always try to keep questions there, है ना? So we have mostly questions here, so this class will be quite easily over. Then we have integrated rate equation. This is quite important. ठीक है, तो इसको हम लोग देख के चलते हैं.